I'm going to do a visual of ionic bonding. There's sodium, it has one dot, one valence electron, and then chlorine, it has 7 valence electrons. 6, 7. Okay. Now, chlorine wants to draw electrons to itself. Chlorine is greedy. So it's going to transfer that electron, it's going to take it, it's going to snatch it, it's going to draw it to itself. Chlorine has 7, but it wants to have 8. That's the octet rule. So in order for chlorine to do that, it's going to have to grab the electrons. So it's going to grab it, it's going to draw it to itself right there. Oh, it's going to take it and take it and take it. Now it has 8. But what's interesting about that is sodium also has 8 now. Okay, let's go with 8 for chlorine. Now, initially, chlorine had 17 protons. It still does. But initially, it also had 17 electrons. So it would be 17 protons, and it was 17 electrons. That would make it 0, a neutral atom. But after it gained that electron, it's no longer, see, it has that extra electron right there. It's no longer 0, because now it has 18 electrons. And now the charge is -1. And we call that an anion, because any atom with a negative charge is an anion. We call it an anion. So chlorine has a negative charge. We call it a chloride ion. Chloride. So when we form that, we add the IDE at the end instead of chlorine. That -1 charge. And we write it like this, Cl minus. We don't actually write the 1. You might see the 1 sometimes, but usually it's understood to be a 1. So that's the chloride ion right there. And sodium wants to lose electrons, so it doesn't have a high electronegativity. It's really glad. And what's happening is this is called transfer of electrons. It goes from sodium to chlorine. That's called a transfer of electrons. And this is what an ionic bond is. It's this electrostatic charge between two ions because of a transfer of electron that occurred. Sodium transferred an electron to chlorine. That's the key to what an ionic bond is. You see, sodium has a low electronegativity. It does not want to keep electrons to itself. It's the easiest way for sodium to fulfill the octet rule is to lose 1 electron, not to gain 7, because gaining 7 is too much. It's easier to lose 1 electron. So they're all seeking to fulfill the octet rule. That's what they all want to do. As you see here, it's a +1 charge now. See? +11 -10. It used to be -11 and +11, but that changed when it lost its electron. It became -10 because each electron, remember, is a -1 charge. So losing a -1 when you were originally a -11 means you now are a -10. So let's look at this picture. We have a nucleus in the middle. Here's sodium. Has 11 protons. We know it's sodium. Whenever you put 11 protons in the middle, you know that's sodium. Got 12 neutrons. We have the first energy level, which has 2 electrons in it. The second energy level has 8 electrons in it, so that adds up to 10. But we have this third energy level, just remember period 3, and we have this third energy level that has an electron in it, just one electron. That's the valence electron of sodium. That's that dot in that dot diagram where sodium just has one dot. That last circle. See? If it wasn't for that last circle, it would have 8 in that second circle. So what is it going to do? It's going to get rid of that electron. Because once it gets rid of that electron, it will then have 8. So that's what it does. Let's chlorine take it. Okay? And that's what the dot refers to, the dot diagram. It refers to these electrons in these shells. And now, look, 1, 2, 3, 4, 5, 6, 7, 8. See, now it has 8. Okay? Now, remember, again, I want to reiterate, it would normally be a neutral atom if it did not do this. But in nature, sodium will always do this. It would always has a tendency to lose electrons. So you won't find just sodium laying around. Even if you had some pure sodium, it would automatically start reacting with the air. It wants to lose electrons. It does not want to remain a neutral atom. It wants to lose electrons. So chlorine wants to gain and sodium wants to lose. The metals gain electrons, the nonmetals lose electrons. Remember that when you're talking about ions and ionic bonding, the nonmetals gain and the metals lose. Okay?